This is a continuation and review of trusses. We already looked what is a truss, the type of trusses. We will review these concepts and determine if a truss is statistically determinate. Also, if a truss is rigid. We know that a truss is a type of structure that have normally straight members. We imagine that the members are pin connected, that there is a pin that connects them and there is frictionless. The loads usually are applied only at the joints. Members and forces need to be collinear and oppositive for equilibrium, and members in tension or in compression are present in the truss. When we calculate truss, we imagine that the truss are of two dimensions, like planar. And we look here how we have pins between them, and the forces will be always along the axis, the internal forces of the truss. Well, some members will be in compression, some members will be in tension. If the members are not straight, well, we will also have moment in the member. When we calculate what's going on in each one of the members, we will realize that some members are in compression and some are in tension. There are many types of trusses. We already studied them. The most important are Warren trusses, Warren with verticals, Howe, Pratt, Parker, and others. Trusses normally are rigid. When the truss is rigid, the member will not collapse due to geometric instabilities. Well, usually a rigid truss will be composed by triangles. When we have a truss like this one that doesn't have a triangle, it starts to be a non-rigid. I mean, it can deform with the change of dimensions of the members. Simple trusses are the ones that are built by starting with three members, I mean, starting with a triangle that we have here in red colors, and after, for every one of a new joint, we have two members. That is the easiest way to make a truss, and it's the way that usually we use in order to do the project that you will be working. Well, we start with a triangle. Let me change here. That will be this one. 1, 2, and 3. And after, for each new joint, this one here, for example, I will have two members. Another two members will make another joint, etc., etc. There are trusses that are not so rigid. For example, we have here an example of a truss that is not rigid, where we are having elements that are not working in the same way, because we can have difference between them. However, when a truss is a simple one, the one that is made by a triangle and another triangles, one after the other, it will be always rigid. Another thing important is if the truss is statistically determinate. What that means that the relations and member forces can be determined by using equilibrium equations. If the number of members and the number of joints is adequate, the truss will be determined and we can calculate using equilibrium equations. If we have more members or more joints of the ones that we are supposed to have, then we will need to use different methods that we will not be working in this class. Let me explain that. For example, imagine that we have a truss that is made by triangles. We start with one triangle, and after for every triangle, for every two new members, 1 and 2, we have one joint. And we continue doing always the same. We have, for example, one member, another member, and one join. One member, another member, and one join. But if I do something like this, then we have one new member, and we have one new joint. Then we have here more joins of the ones that we are supposed to have. We can also have something like this. 1, 2, 3 members and 2 new joins. Well, we have now more members than the number of joins that we are supposed to have. And how we calculate that, that is something that I will be explaining next. That have to do with the equilibrium of equations in each one of the joints. Well, the summatory of forces and summatory of vertical forces and horizontal forces have to do with the rules of trigonometry. And the total of number of equilibrium equations in every available joint should be the number of joints multiplied by 2. If all joints are in equilibrium, then the whole structure is in equilibrium. Well, the total number of unknowns is something similar as we had before when we have a beam and we are supposed to do a summatory of moments and a summatory of forces. And if we have two unknowns, then we need to use the number of, if we have that particular case, then we need to calculate the moments in each one of the reactions because doing the summatory of forces, we cannot do it. Well, something similar happens when we speak about trusses. This may sound complicated, but I will show a formula that will help us to understand very easy what's going on. Well, the number of equilibrium equations is the number of joints multiplied by 2. How that work? Well, for example, here we have a truss where the number of members plus 3 is equal to 2 times the number of joints. That is the formula that we need to learn. And it's important to understand this formula here. Well, M will be the number of members. And we can look here, the members are in white colors, and we have 1, 2, 3, 4, etc. We have 11 members. The number of joints are in blue color, and we have 1 joint, 2, 3, 4, 5, 6, and 7 joints. Well, in order to have a truss that is determinate, we need to do this formula until M, that is the number of members, that in our case is 11, plus 3, need to be equal to the number of joints, that in our case is 7, multiplied by 2. That means 14 is equal to 14. If that happens, then the truss is determinate. When you need to design a truss using our method of Maxwell diagram or graphic method, you need to make sure that the truss that you will design have and compile with this particular rule. If not, you will not be able to calculate the truss and all your problem will be grown. Let me clean here everything and continues. This is a truss that is statistically indeterminate. statistically indeterminate because we have one more member of the members that we need to have. It's the same trust that we had before, but I add a member here in the middle. Well, look, I add one more member and one more join because this join number 3 already exists. And that doesn't go with the rules. If we are not sure, we just need to calculate. And here we see that we have, in this case, 7 joins, one more join than before, and 12 members, one more than the first example of the determinate truss. Well, the number of reactions is 3. I mean, here we have this reaction, here we have this reaction, and in the case of this particular one, because we have the little car, we will have another element like this. We can also think that the first truss is made by a triangle that is 3 numbers, and the next one will be 2 more members. 2 more members. Well, that's why we put the number of members multiply, the number of members plus 3, that is the original one. Well, in this case, the equation doesn't work. 12 plus 3 is not equal to 7 plus 2. 15 is not equal to 14. Is false, therefore, is an indeterminate truss. Let's go with another example. In this particular example, I already passed it. Let me go back. In this particular example, I eliminate one of the members. From the original truss, I eliminate the member that go between the joins 4 and 6. Well, we have the same number of joins, 6, but we have a number of members that is inferior. Well, when we do this particular equation, we realize that also is false. It's not working. Well, it's indeterminate. Let me clear here and go to the next one. Well, the statistical determinate truss will be truss where the equilibrium of equations and joins will work perfectly, that we will have a number of unknowns that is equal to the number of total equations, therefore we can resolve the truss easily. A truss that is indeterminate, like in this case, for example, we have more members of the members that we need to have, and we have spaces where we don't have joins. For example, one member is in front of the other, but there is not a join. And well, this truss will not be able to be calculated. Well, you need to be very careful when you design your truss that your truss is determinate because you need to calculate it. Well, as a summary, trusses consist of pin joint members only in tension and compression. Statistically determinate truss need only joint equilibrium to find members forces. Rigid trusses do not allow joints to move under small perturbation forces, and simple trusses can be made by adding 2 members and a joint to a rigid structure. Well, your truss not necessarily need to be a simple truss, but you need to make sure that you are able to calculate and make a truss that is determinate. This concludes this presentation.